Hello everyone, and thanks for joining me at the Red Team Village. My name is BitK. I'm a bug hunter and CTF player with the Flat Network Society. We were the winner of last year NamCon CTF, and my specialty is about web exploitation. I'm also working at YesWeHack, and I've been doing a lot of open source projects recently. For example, YesWeBurp, an add-on for Burp Suite that allow you to import your settings from YesWeHack directly into Burp. CTF Note, a tool for CTF players that help them manage their team and collaborate. And Poonfox, an add-on for Firefox that facilitates the pen testing of application with multiple profiles by allow you to do compartmentation. I'm here today to talk to you about XSSs. Why talking about XSS? First, I think XSS is one of the most commonly found on bug bounty program. I think every bug bounty program, in the activity of the program, there is at least one XSS. Why? Because a lot of hunters are looking for them, because it's quite easy to understand and quite easy to check if the bug is really there. You can just try and inject some HTML. If something triggers, that means that your XSS is working. And also, it's very common because it's difficult to identify and to protect yourself against it. If you have a user input, you don't need to escape it the same way if it's in a HTML context or in a JavaScript context. There is also a lot of DOM-based XSS, and JavaScript being JavaScript, there is a lot of weird thing going on that can lead to XSS. The second thing that got my attention is there is a large payout diversity between XSS. On some program you will get paid $50 and on other $5,000. But even on the same program you can see XSS ranging from very low payout to very large. So why is this? I think XSS is often underestimated by program manager and developers. And why is it underestimated? I think it's because most of our POC, when we submit a report, do nothing. Usually we only use an alert just to prove we are able to run JavaScript, but we stop there. And I think because of that, the idea of an XSS for developers is only, oh yes, an attacker can start an alert box, or an attacker can steal my cookies. But they don't see the full impact that an XSS can have. For example, I've seen programs where XSS were out of scope, but CSRF were in scope. And that's a bit ridiculous, because with an XSS you can do basically the same thing as what you will be able to do with a CSRF. So how can we help program manager and developers to better understand the impact of such bugs? We should write better payloads. But writing better payloads can be very time-consuming, and if you are doing bug bounty, you know that time is often the key for a report being accepted or duplicated. It's often repetitive. You don't want to spend a lot of time every time writing an exploit that will fetch something like a token, a self-ref token, create a form, update something on your profile. It's a lot of work, it's often the same thing, but it's also always a little bit different, so you cannot really reuse your payload every time. And there is a lot of pitfalls to avoid. For example, you will have payloads when you need to encode, URL encode your payload, and then HTML encode, and then something else, and somewhere in the middle you forget something and nothing is working anymore. You don't know why, and it takes a lot of time in debugging and making everything work again. I will show you how I used to write payloads and how it was inefficient and how I get stuck all the time because of encodings or double quotes going somewhere I don't want to and breaking all the payload. Because of all the CTF I've played and all the bug I found that was XSS, I think I started to get bored of writing always the same thing over and over. So I started working on a library to help me write more efficient payload in a shorter amount of time. I came up with xsstools, a tool inspired by Tools. If you've been playing CTF or writing exploitation, binary exploitation, You already probably know puntools. It's a set of functions that will help you write your exploit. So I wanted something similar, but for XSS and other kind of client-side bugs. You can think of it basically of a jQuery for XSS. It's not required to write payloads, but it will help you to write them quicker, and it will already include all the most common functions you will use when writing an XSS. One of the plus side of the lib is only required to write the exploit. That means you need to run it on your computer, but after that the exploit generated with the lib will run as a standalone exploit. Enough with the slides, let me show you some real examples so you can better understand what I mean. To do my demonstration, I will use the public firing range by Google. It's a website vulnerable by design, when you can test your XSS payloads and check if everything is working as intended. For the demo, we'll use a simple injection, a reflected XSS in a parameter body. This is the most simple way you can do an injection. Let's just test it in the URL. Okay, so we have our title. This page is vulnerable to XSS. What are we going to do? We are going to try to write a payload that when the payload is triggered, it will fetch the index, read the title, and send it back to my server. This is very similar to something you would do, like fetching, for example, a user token or a CSRF token or something like that. So this is how I use to write payloads. So what is the goal again? We want to fetch slash, read the title, and send it back to the server. But first we want to be sure that everything is working as intended. So we take the URL and build a small payload. We just want to do an alert and test it. This whole code is wrapped in the Go function, so I need to click on this button to trigger it. Let's see what it looks like in the browser. Here we can see the button Go, so let's click. We are redirected to the firing range and the XSS is triggered. The alert one is showing here. But now we need to complete our goal of fetching the title and sending it back to the server. So I've updated my payload. Now it's fetching the slash, read it as text, then use the HTML in a regex to extract the title. And when the title is extracted, it's send it back to my server using fetch. If we try to run this payload again, we get an error, and this is quite obvious why. Because our payload is no longer a single line, it breaks the HTML syntax and nothing is working anymore. So we need to fix that. So let's go back to the payload. I tried fixing the payload by replacing the double quotes by the HTML representation and removing all the new lines. And on top of that, I'm wrapping the payload inside double quotes. So now it should be working. Let's test it on Firefox. Okay, once again, it's not working. Why? It's a invalid regular expression flag T. So why is that? Let's look at the code again. If we look at the code, the bug is just over there. Because we don't want the slash to be the termination of the regex, we use the backslash. But this backslash is escaping not inside the regex, but inside the string inside our function Go. So we need to double escape it, and now we can try again. The payload is bugging because we use the regular expression over there, and to make it work we had to escape the slash. But here the slash is not escaped in the regular expression, it's escaped in the backtick. So we need to double escape this. We also need to add some semicolon to separate these two lines, but finally the exploit should be working now. Let's click on the go button and see if the payload finally works. Now we can see that the request to slash has been made and the title has been exfiltrated, but the request has been blocked by cause. So let's do one last patch to make everything work for real. To avoid getting stuck in course error, I just added this option to fetch with mode no cause. This way the browser won't send the course pre-fight and just send the request without the need to read the answer. So let's test this final payload. And we click on the go button for the last time. We can see that the request to slash has been made, the title was exfiltrated, and there is no error anymore. So now the payload is working. But it was a lot of back and forth between testing and writing the payload. There is a lot of ways this can go wrong. For example, if there is like a comment in my code, putting everything on one line can break everything. So depending on the payload, we cannot just reuse the encoding parts. And this is how I write my payload now. So first I define an exfiltrator. This will be the part of the code responsible to exfiltrating any data back to my server. For this demonstration I used the first exfiltrator, this is get, so it will do a get request using fetch on my domain using the exfiltrate parameter. Then I create a payload with payload.new. I add my exfiltrator to the exfiltrators list because I can use multiple of them. I ask the payload to fetch slash as a DOM element, so it will return me a document element of the main page of the index. Then I use query selector on this page. I look for the title tag and I get the inner text of the tag selected with the query selector. And then I call the exfiltrate function that will loop over all the exfiltrators and exfiltrate the data. But this only gives me GS code. So now I got some GS code. I need to wrap it in some kind of executor. Like before, we wrap it in a svg load tag. And we call the wrap function on the wrapper to get the final payload. To display the payload, I use some utils function available with the template I will show you in a bit. So a log, just to send some message to follow the execution. Then I build a URL. It's a simple URL builder taking an URL and an object for the get parameters. And then I append the frame in the template. Let me show you. This is what the template looks like. It's divided in two parts. On the left you got a console for debugging purposes, and on the right the list of frames you've opened. Here we've opened the firing range, but it's blank on blank. But you can see in the request that the frame was opened here with our payload. Then a request was made to the index, and then the exfiltrate function was called. The data is sent as base 64 to avoid any problem with encoding during transfer. If you don't have a server but you still want to prove that you're able to exfiltrate data, you can do it only on the client side by using post message to prove that the frame that is being exploited is able to communicate with the top frame. Let me show you how to do this with xsstools. Instead of using the get exfiltrator, I will use a simple post message exfiltrator to send the data from the exploited frame to the top frame. I can put another frame name here, but by default it's top. Let's see what it looks like now. This time when the payload run, instead of sending the data back using a get request, the data was sent back using a post message, and we can see it here displayed in the console. So this is a good way to prove that you are able to steal data from a remote server without the need to have your own server. This is a fairly simple payload, but xsstools is way more powerful than that. Let's build something better. On top of what we already have, let's add a keylogger and a click-logger. So let's start the click-logger first, and then we start the keylogger. Automatically these two functions will call the exfiltrator to exfiltrate the data, but you can submit your own function over there if you want to do something else. Let's use the exfiltrator first. The exploit looks the same, but now if I click on the page, I can see that the position of my click and the HTML elements under the click are exfiltrated using the exfiltrator. Also, if I type on the keyboard, all the keystrokes are sent back to my server. It's easy to deploy, and I didn't have to modify anything in the wrapper. That means now all the payload code and the code responsible to wrap everything and make everything execute are totally separated. I can update one part without touching the other part. So how those xsstools works? xsstool payload are written a bit like shell command. Here we can think of this payload chain as something like, first we call new to create a new payload, then we add our exfiltrator that we created before, then we start the keylogger, following by the keylogger, then we fetch the DOM /. We use query selector on it to get the title, and we take the inner text of this title, and then we call exfiltrate. So this is very similar to a shell command if you think of using dot the function as a pipe, because every command output will be forwarded as an input for the next one. Let me demonstrate using a more complex payload with xsstool. So we start with a fresh payload. We just add our exfiltrator. This time we still want to fetch the DOM on /, and we will try to get all the link on / and get the URL of the link and exfiltrate this. This is a good way to discover hidden website if the XSS is blind, for example. So I will use query selector all. I will look for all the links, and I will get the href element. Then for each of these elements, I will create a new payload, and I will call exfiltrate. Now when we open the page, the XSS will trigger, fetch the index, and send us back all the links. You can see here in the console that all the links and all the href attribute of each link have been sent back to my page. xsstool comes with a large choice of already available functions that will help you build the payloads rapidly. Each function comes with an example and a little bit of graphic to show you how the payload behaves according to the pipe system on xsstool. You can find the documentation with the source code on the GitHub. But if you are already very familiar with JavaScript, you might want to write your payload by yourself and only use the wrapper function. This is still possible. Let me show you. If you don't want to use the function built-in, you can always create your own using eval. That way you can do complex operations that are not pre-offered with the tool. I don't know, for example, accessing the local storage or stuff like that. You can always use eval. If you return something, the return value will be put in the pipe and will be usable by the next function. For example, here I can use another eval, and let's multiply the value by 2, and finally let's call exfiltrate on it. Here we can see the payload triggering and sending back the 84. That means you can write your code either using xsstool function or your own, or even mixing them to build something that suits your need. Now that you're able to build your payload efficiently, let's talk about wrappers and how you can deliver those payloads. Until now, all our payloads are executed using the svg load function. This will build a payload looking like this, svg onload and the payload here. But sometimes you are not able to use the on event triggers because they are blocked by a WAF or they are simply not available in the char set you have. So maybe you want to use something else, like just using a script tag, for example. This time the payload will look like this. But this doesn't always work, because if you are in a context where the payload is injected using inner HTML payload, this won't work. The script needs to be passed as a document element. To do so, we can wrap the payload in an iframe, for example, with an xsstools and the payload inside of it. To do that, you simply add a new wrapper to your wrapper chain, let's say iframe, and now the payload is wrapped like this. But if your input is not injected in an HTML, for example, and it's injected in JS, and you want to use document.body append child, something like that, with this iframe, with the script inside of it and everything, you can just continue to chain all the wrappers and build a very powerful chain of wrapping. This might look useless because you might say, oh, why would I want to wrap an iframe inside a script, inside a document body and everything? It can be used to bypass WAFs. I've been able to bypass Cloudflare WAF using something similar and get an XSS on Starbucks, for example. When the payload trigger, it will create a frame in a frame in a frame that will load our JS code. So we can see all the frames here. We can see the code is still executed and we got the callback. Let's take a closer look at the source code of this frame. We can see here our injections. So we have the iframe xsstools inside an xsstools, inside an iframe, inside an iframe, inside the template function, and here is our code using no parentheses. This is very powerful because you can totally separate the effective code you want to run and the way you will be running it. Once again, the documentation for all the wrappers is available with the source code, and you can see for every function what it does and how it can be used, and a simple graph to know what is the output of each function and how you can chain them and use them in a payload. If you want to use the wrapper but you don't want to use the payload generator, you are always free to use the wrapper with a string instead of a payload. For example, here I will just want to call alert1 as a payload, but I still want to use the previous wrapper that will do minify, template string, script, iframe. Let's test this. Once the page loads, you will see all the iframe and the alert trigger. This means the code was executed properly inside all of our wrappers. This is good because that means if you want to use only the wrappers from xsstools, you can. If you want to only use the payload generator, you can. You are not stuck with the whole frameworks, you can only use what you need. XSS is not the only bug on the client side. You can also find some clickjacking on websites. It's easy to find when it's there, but it's often difficult to exploit because you have to make everything line up perfectly, and it can be very fastidious. Here I've built a small example using the XSS from before. So I will just load the page and I will just add a button. When it's clicked, it just shows an alert saying OK. But you can think of it of, for example, reset password button or delete account button. This is what it looks like in Firefox. We have the frame with the button, and if we click, we got an alert. Now we want to trick our victim into clicking on this button without knowing about it. To do so, I've created a new clickjacker class. I've given the clickjacker the URL of the website I want to clickjack, and I've added a step. Each step is a button you want to push. Here I put the X and Y coordinate of the button. I can put a width and height, so it will be automatically centered. And I can call clickjacker.run. Let's see in action what it looks like. Now, when I open the page, I will be greeted with a pop-up, but if I click on the button on the top right of the pop-up, the click will in fact trigger on the hidden frame, and the alert text box will be shown. Here you can see. That means that the click didn't happen on my page, but on the targeted web page. This time there will be 3 buttons on the page, and they will need to be called in the right order for the payload to trigger. So I've added 2 extra steps on my clickjacker, and I call run once again. To trigger the alert, we need to press the button in the right order. If we do it in a different order than 1, 2, 3, nothing is happening. So let's try 1, 2, 3, and we got the OK page. Let's see how the clickjacker handles this. So I will refresh the page. I got a pop-up open on me. I can click the first one, the second one, and then the last one, and the alert trigger. So this works very well even with multiple steps. Usually you are not able to catch events happening on an iframe, but what I did here to make this work is basically I have a hidden field with the focus, and I wait until the field loses the focus, so I detect that the click is happening outside the frame. So this lets you use a multi-click payload for clickjacking in a very, very simple way. xsstools also include a full list of tests. That means you can run all those tests in the browser you want to target to be sure that every step of the process is compatible with the targeted browser. Thank you everyone for listening to this talk. I really hope xsstools will help you to build more efficient payload, and you will be able to get better reward with it. If you want to test it, you can download it right now on GitHub. It's at github.com/yesreact/xsstools. All the documentation and the test suite are available in the GitHub. If you are interested by other tools we've been building with YesReact, you can check yesreact.github.io. And if you want the latest news about everything we do, we can follow us at BitK or at YesReact on Twitter. Thank you everyone, and goodbye.